Welcome to welcome to my channel. So let's solve today's Leetcode Daily challenge problem. So first, let's discuss what the question is asking. Then we will try brute force and then a better approach for this problem. It's a very tricky problem. That's why it's given us so hard. So let's try to understand what the question wants us to say. Let's copy this. So okay, in our problem we are given a array ideas, and we have to we have to form new names. And how can we form new names? We have to find the count of the new names, new valid names, and what are the conditions according to which new valid names will be formed. Just like if we take any two words from the array of ideas, coffee and donuts, we are going to swap the first letters of both of these words. That is D and C. And if two new words are formed, then we are going to increment our count by two. That much means we got two valid distinct names. Got it? That is Doffy and Connuts. And when will two valid forms will be not formed? Just like in the case of toffee and coffee, we are going to swap C with T, and we will get coffee and toffee again. So this won't give us the condition. And just like we will do a swap with coffee and time. We will get Sime and toffee, but toffee is already present, so we will not increment our count by plus two. So how can we solve this problem? So what first of all, what we can think of is a brute force surface. We will store all of the strings present in the array ideas in a map or in a set of strings, and then we will from each index we will traverse up to the end and do a swap and check if it's present in the not if the after swapping the two new names are present in the set or not. If they are not present, we will increment by plus two. Okay, and if their twos are not present, we will increment by plus two. So this is a brute force way, but it will give us TLE. Okay, so we have to find the valid number of names. Another brute force way which can think of is I will just maintain a map in which I will do the swaps, and if that's not present, increment the I will put it in the set and I will return the set size. But this will give us TLE. So we have to think of a better way, better approach. So what our approach is that we have to observe that only the first letter is going to swap, and how many possible choices we have for the first letter for each word. 26. Okay. So at the position of coffee, we can have toffee, we can have moffee, we can have boffee. Okay. And suppose we are swapping coffee with donuts, and for the position of donuts, what can we have? We have donuts, we have conuts, we have monuts, something like that. At most 26 choices. Similar for coffee, we have at most 26 choices. So we can understand that we can reduce its time complexity to something like in the form of 26 into 26 into something into n. So this is our first thing. We have to think in the form of the letters. How many choices, at max choices we have. So the other thing is that their suffixes doesn't play a role at all. The what plays role is the first one. If from coffee we are going to form if we are going to form doffy, and from conut we are going to form from donut we are going to form conut. So that is going to give us one pair of valid swaps. So one pair of valid swap will give us two increment. Okay, and if we try to form a matrix of 26 into 26 letters, and for each if each valid swap, that is for if we try to traverse 26 times for the first one, and if the resultant word is not present in a set of the strings of ideas, then we will increment our that one by plus one. But in our answer, that will give us result only but when adjacent to this or something opposite to this is formed. That means that if we are making doffy from coffee and cornet from donuts, only then our answer will incremented by 2. Just like we can also give our valid position combination with our valid swap will be Zophie also. But there is no Z word present in the starting from Z present in the array. So our in our answer it won't be added. So in our answer only valid position of one swap and two swap. If only both of them are present, only then it will be added. And we will run a loop two times over this 26 and 26. Only if I and J both are present, only then our answer will be incremented. So let's form a matrix clearly and then another again understand. So just like this. A, B, C, D, E. A, B, C, D, E. For example, coffee, donuts. Okay, let's run a loop of 26 over the first position of coffee. We were going to form A of E, B of E, C of E, D of E. For each of them, we will increment the position by 1, 1, 1, 1, 1. So let's do for D. For D1, okay, for D and okay, we going to C and D. C and D. We are going to change C from C to D. C to D, 1 plus 1, here it's 1 present. And similarly, from D to C, here it also 1 present. And we will run a for loop over them and multiply these two. Similarly, someplace here it will be 0, someplace it will be 1. But only if this possible swapping is happening, just like from C to D and from D to C. If it's present in our matrix, only then our count will increment it or plus 2. Got it? That's the that's the core concept of the problem, and that's how we will solve it. Swap C with D, not this in matrix. Swap D with C, not this in matrix. Only if both of them are present, increment our count by 2. In every other case, just like we swap C by A, but we don't have any A to swap with D. So our answer will not be incremented, so it will simply give 0 because the only matrix is only pre-filled with 0. So let's try to implement it so your understanding will improve by seeing this implementation. So let's first form a set of strings from which we can check at each point if it is present in our array ideas or not. So let's start with this. We will maintain a set, and set will contain all the strings present in the ideas, and after that a count which is our result, and a matrix to check our valid combinations, a valid combinations of uh, something like ij with ji. In rest of all the cases where j and I are valid swaps of the first word. Okay, so it's like 26, 26 and 0. So this is a matrix. So let's now iterate over the string ideas, array of ideas, and try to replace first letter by all 26 choices. Just like we have given our first word is that, our word is that, string temp is equal to IT. This is our string, and we will try to replace its first letter with all possible choices. That is from A to Z. From A to Z, we have choices. Okay, so now let's replace it, and we have to see after swapping if it's not present in our original ideas. That means if st count not present in our ideas list, we will increment the matrix. That means that we will increment the matrix where we going from it 0 to x. Okay, so that's what we will implement in matrix. But in our count, it will be only added when also x to it 0 is present. Then count plus 2 into frequency of how many swaps of both of them are done of temp and temp and x. Oh, sorry, it 0 and uh, x. Got it? Because it's possible that for the same letter we are changing same letter in many words. Okay, so let's try it. It's not present. Then we will increment matrix uh, it 0 and temp 0, it 0 minus 0, x minus a. Sorry, a plus plus. So that's how we will fill our matrix. And now let's just traverse over the matrix and try to see if any combinations are getting formed. And if they are getting formed, that means not both of them are not 0. Then we will multiply by 2 because two valid words are formed. So let's now check if it's working or not. I hope it will work. Okay, so now let's try for second test case. Okay, now let's start to submit this. Okay, it's working. So let's finally discuss this time complexity. The time complexity of this code will be big O of 26 into 26, 26 into 26 into n. So the crash of the question is that we are going to choose the fact that only first letter is getting swapped. Only first letter is getting swapped. And at max, how many swap is possible for first letter? 26 swaps. So we'll generate all 26 swaps and mark for each one of them. Only if pair is getting formed. If only if that pair is getting formed from if we are getting a pair from x to y, that is x is getting transformed to y and y is getting transformed into y is getting transformed into x in some of our swap, which will be noted in a matrix. Only if both are present in our ideas, then we will increment our count by 2 into frequency of both of them. So okay, thank you. That's today's Leetcode Daily Challenge problem.